Hi friends, today we are going to discuss about the buck converters, DC to DC converters. Okay, then see, into these buck converters we are having the basic components, right? Then which one is the basic components of a buck converter? One is the MOSFET, diode and inductor, output capacitor and this input capacitor, right? These are the basic building blocks of a buck converter. Okay, then if this is a very important questions, even into the interview they are asking like what is the architecture of buck converters, can you please draw the architecture? Then definitely you have to make in a such way like one MOSFET should be there, and after that this inductor, output capacitor, this diode and this input capacitor, input voltage, load resistors such that across you can get the output also. All these things you have to make it, and it will be a complete circuit diagram of a buck converters. Okay, as basics you know, like the buck converter are having the two types basically. Okay, one is the synchronous buck and that one is the non-synchronous. Okay, then there is the one difference over there. This is the non-synchronous buck converters. Like if you will remove this diode by using a MOSFET, then it will be a synchronous. That is the difference only. Okay, and why we are using that synchronous, like in the recent designs and all, you will see you are using this type of a buck converters where you are, this diode is not present. Okay, in place of the diode one MOSFET is there. Then what is the advantage over there? The power dissipation. Okay, the power dissipation, it will be low. According to that, like your losses will be low. Okay, and your efficiency will increase. Okay, let's discuss about the all these cases. Okay, then see, this MOSFET is working as a switch here. Okay, here some one IC should be there such that it will control the duty cycles of your MOSFET here. Okay, then there could be the two cases. Case 1 when your MOSFET is on, case 2 when your MOSFET is off. Okay, then see, let's discuss about the both the cases. In the case 1, what happens basically, when the MOSFET is on, then at that moment this circuit will happen. Your MOSFET will be, your drain to source, it will be connected and your current will be flow like this. Okay, at that moment your diode, it will be into the reverse bias such that no current will be flow and the current flow in this path. Okay, across the capacitor, across this load resistance. Okay, and diode will be the reverse bias such that it will be the off mode. Then at that moment, if you have to be follow like how you are getting the output, you will get the output like this. Okay, your current is following in a such way. Okay, the other case, what could be other case such that your MOSFET is off, then in that case what happens, there no input current, it is going across the whole the circuitry. Okay, then what happens, in the first case your inductor and this output capacitor, it was got charge. Okay, then into the second case when your MOSFET is off, at that moment it is whatever the charge is stored into the inductor, it will flow across this output register like load registers. According to that you will get the output. Okay, and it will follow this path. In this moment what is happening, your diode will be into this forward path such that it will follow this path and your current flow will be like that. Okay, then see, as you already discussed, like these things, the case 1 and case 2, it was happening over there. And but again, if you have to be calculate like what is the efficiency and what is the input voltage of a buck converters and how you have to calculate, let's take an example. Okay, see, if you are having a buck converters and the input voltage is the 12 volt and the output voltage you required like the 5 volt and 1 ampere. Okay, then the based on the duty cycle, basically you can calculate like what is the input current it is required here. Okay, then see, what is the duty cycle? Duty cycle is nothing like that is the output voltage upon the input, right? Like what is the output you required based on the input, according to that the MOSFET gate is switches on, switches off. Okay, and see, here is a very important thing, like if your voltage is changing such that it is a buck converter, such that from higher voltage the voltage is getting converted into the lower voltage like 12 to 5, and here your current is the 1 ampere, then see in that case if your voltage is decreasing from 12 to 5, your current it is increasing, right? Your here is a 1 ampere into the output, into the input, that is a 0.46 ampere. Okay, always remember this. See how you have to calculate your duty cycle or the time period. Okay, see this is the complete, you can say one waveform where is your T on and the T off cycles are happening. In that moment, if the T on cycle is for the 1 millisecond and the T off for the 3 millisecond, okay, then the total time period it is a 4 millisecond. Okay, then in that moment T on is the 1 millisecond, T off is 3 millisecond, T and T on, T off. If you want to calculate all these things, how you can calculate? You can calculate like the total time period it is the 4 millisecond, frequency you can calculate, duty cycle also you can calculate, T on upon T on plus T off. Okay, such that you got like the 1.4 25% here. Then you can calculate like what is the output voltage you should have to be get. According to that you are getting the output voltage 3 volt only. Okay, but what you want the 5 volt. Then what you have to do, you have to adjust your duty cycle. How you will adjust? With this T on the and the T off cycle. According to that your output will be calculated. Okay, I think it was clear for you. And how this MOSFET gate it is controlled by a switching circuitries. Okay, some switching ICs are there. According to that, like with whatever the feedback mechanism was following over there, and due to that what happens, it is controlling the on and off of a MOSFET such that your whatever the voltage from the drain to source it can get defined over there, or it can transfer. According to that your voltage can set whatever the required voltage it is there. Okay, see into this case 1 and case 2 whatever we discussed, same funda, right? Like then this is your T on T off pulses, it looks like that. It is the total time period, it is the half of the dt. If I am taking the 50% duty cycle, then see this type of a waveform it should you will get here. Okay, what is that? Basically your inductor current, you can say it has to be, there should be minimum and the maximum values. Okay, such that it will be the output voltage. But again what happens, there should be some ripple factors. Okay, like as you know the inductor current you have to calculate IL is equal to I naught plus del I by 2. Okay, then what happens, see that's why it is going this maximum level of this current, and again it is coming into the minimum level. And how it is happening? This is happening when your MOSFET is on. See this condition, you can see when your T on MOSFET is on, then it is into the rising, and when your MOSFET is off it is into the falling, and this scenario will be continuously following. Okay, then that is the way. And due to that if you want to be calculate like what is the formula of your duty cycle whatever we discussed earlier, okay, then you can derive that formula also with the volt second and the balance equation. Okay, then here what you have to do, you have to be calculate like the area across these triangles, basically it should have to be equal. Okay, basically the energy can't be only energy can be interchanged from one form to another, it can't be destroyed. Okay, that's why this energy should have to be same. Then how you can calculate? You can calculate in a such way like you have to multiply whatever the slope it is there and this time. Okay, according to that if you are calculating the things, then what you will get, you will get this equations such that your slope will be for one, your rising one, your rising, your slope factors is what, your v1 minus v out. Why it is that? Basically it is increasing. How it is increasing? From when your MOSFET is on, and your MOSFET is on, it means what, the voltage from v in to v out, that voltage or that difference it is across your MOSFET. Okay, that's why we are taking v in minus v out, and the same drop we have to take across your inductor also, V in minus V out, and whatever the inductor value we are dividing, that is your slope for the rising. For the falling, what happens? The falling, it will be like that. Again, that is the negative. Okay, the negative is that, that's why this value is coming as a minus 0 minus V out upon L. Okay, and the time period we have to multiply, and such that we will get the complete this equation. Then this one you have to multiply like that, V in minus V out and all dt time period for this rising, and t minus dt, that is your falling. If you will calculate this one, then what you will get? You will get V out is equal to V in multiply by the d. Du is your duty cycle. You got the formula, duty cycle is equal to V out upon V in. Okay guys, then according to that you can calculate your duty cycle, output voltage, input voltage, everything you can calculate. Okay, there is the again multiple fundamentals such that how you should have to be calculate your MOSFET, what is the way such that you can calculate your MOSFET. Again, like there is multiple important interview questions they are asking, like how you can calculate the MOSFET. Can you please tell me? Then again you have to be defined like such that your VDS, ID, and after that your gate capacitance, okay, RDS on, all these factors should have to be low. Okay, the other thing is that they will ask how you have to calculate your inductor. Okay, the inductor also you have to be tell like what are the process to calculate the values over there, ripple factors and all. Okay, the output capacitor, input capacitor, all these factors, there is a formula, but don't go with the formula. You will get this formula into this multiple documents, but just try to understand like how these things are independent to each other. After that what happens, it will be very easy to correlate the things, and after that while you are explaining you can better a way such that how the things are correlating and how it is interchanging basically. Okay, then let's meet into the next video. For that, at least, thank you, and please subscribe this channel. Thanks.